Hey guys, here's the review for your midterm. I'm going to go through a selection of problems from the midterm review and try to do one or two from each topic so we have something to work from. First up, we're looking at graphing inequalities. Now, this is going to be a multiple choice question on your midterm, but we need to understand the principle for how these things work before we can get there. And what we're going to do is graph each of these separately. I'm going to graph that one in purple and that guy in red, and then deal with the inequality part of that afterwards. So for the first one, we've got a y-intercept of -3. We've got a slope of 1, so I'm going to go up 1 over 1, up 1 over 1. And because we're dealing with a less than and not a less than or equals, I'm going to make a dashed line going through this point. On a multiple choice question, the first thing that I want to do is to see if I have any graphs that don't show this line at all. If this line is not there, that can't be an answer. That's a great way to cross some things off. Okay, next thing I'm going to do is to check the point 0, 0. It's not on my graph, so I can use that. And I get 0 is less than 0 minus 3, which is false. If it's false, I'm not going to color on that side of my line. In fact, I'm going to color on the opposite side. So that'd be this side of my graph. Okay, second line, I'm going to look at y is less than or equal, -4x plus 2. I'm going to use my y-intercept of plus 2, down 4, 1, 2, 3, 4, over 1, down 4, 1, 2, 3, okay, I'm off my graph now, so somewhere down there. Less than or equal means a solid line, and I'm going to go up like this. And again, I'm going to make sure that I'm looking for graphs that have both of these lines on them. Sometimes you can get to an answer before you actually finish the problem. Okay, and similarly, I'm going to look for plugging in my origin. So we've got 0 is less than or equal to 0 plus 2. That's true. That means I'm going to color in that side of this graph. So that's this part over here. And this is my final answer, where I can see where both of them are shaded and the parts that only one of the two graphs are shaded. You'd be looking for this picture on a multiple choice question. Here we're doing some factoring. I'm going to look at this in two different ways. The first is doing this forwards, and the second is if you can't remember how to factor, we need a way to solve this problem. Okay, so doing this forwards, we're looking for a times c, things that multiply to 28v squared, and also add up to -11v. Okay, 1 times 28, no. 2 times 14, no. 3 doesn't work. 4 times 7, that's 11. -4 times -7 is what we're looking for. Okay, so that'd be 2v squared minus 4v minus 7v plus 14. I look at my first two, they can take a 2v, and I'm left with v minus 2. For the next pieces, I can divide out a -7, and I'm left with v minus 2. That gives me v minus 2 and 2v minus 7, which happens to be answer choice D. If I don't remember how to do that, one of the things that I could do instead would be to multiply these pieces out. So, for example, 2v plus 7 times v plus 2, that would be 2v squared plus 4v plus 7v plus, I was about to say 9, but that's plus 14, which does not give me the same thing as my original question. That one doesn't work. I could do the same thing for each of these answers, and in that process, instead of actually factoring, I could multiply to see which one gives me the right question. Here we're looking at operations with complex numbers. Realistically, this is just combination of like terms. And what I'm going to do is take -6i and go minus -8i, and -6 minus -8, so -6i minus -8i, is positive 2i, and then negative 3 minus 7. So negative 3 minus 7 is negative 10. The answer here would be negative 10 plus 2i. Again, just combination of like terms. To write a polynomial function of least degree using zeros, what we have to remember is that if a is a 0 or a root or an x-intercept, what that really means is that x minus a is a factor. So to write a polynomial, what I'm going to do is take each of these and go, instead of 1, x minus 1, instead of negative 2, x minus negative 2, and instead of 2, x minus 2. If you wanted to rewrite this, you could as x minus 1, x plus 2, and x minus 2. You could multiply this out, but we're probably not going to ask you just for the sake of time. And by probably, I mean we're not going to ask you to do that just for the sake of time. Here we're looking at some properties of exponents. I'm going to handle this in two parts. First, I'm going to deal with that 2 in the exponent outside the parentheses, and then combine what I can. This is also the part that's going to trick you in terms of the problem. So that 2 is going to go to each exponent here. We know there's really a 1 hiding on the 2 in front of the problem. 1 times 2 is 2, so 2 squared. 4 times 2 is 8. 2 times 2 is 4. And I'm just going to carry that a to the third down. Okay, 2 squared is 4. And you might notice that the only one of these that has a number out front that's 4 happens to be c. So you're done with the problem if you figure that out. Or you can keep going. A to the third times a to the eighth. 8 plus 3 is going to be a to the 11th. And then we've just got b to the 4. And again, that's going to be choice C. With the polynomial operations, we know we have to do some distribution here. I've got multiplication between them. So we've got 5x times 3x squared, that'd be 15, and then x to the third. 5x times negative 6x is going to be negative 30. And then x squared. 5x times minus 3 would be minus 15x. Negative 6 times 3x squared is minus 18x squared. Negative 6 times minus 6x is plus 36x. And negative 6 times minus 3 is plus 18. I'm going to combine some like terms. Nothing goes with x to the third, so I've got 15 x to the third. With negative 30x squared, I've got negative 18x squared, so it's minus 48x squared. With minus 15x, I've got plus 36x, so that's plus 21x. And then I've got plus 18 all by itself. Next up, we got a factor completely. This is quadratic-like because I go from 4 to 2 to 0. And for that, I'm going to treat this as though it were quadratic. So a times c, we get negative 3x to the fourth. I'm trying to add up to b, which is 2x squared. Negative 3 is going to be negative 3x squared and positive 1x squared. No, that goes to negative 2. How about positive 3x squared and negative 1x squared? If I add those together, I get 2x squared, so that's my winner. So we rewrite as x to the fourth plus 3x squared minus 1x squared minus 3. I'm going to factor this by grouping. The first pieces, I've got an x squared in common. That leaves me with x squared plus 3. And for my second pieces, I've got a minus 1 I can take out of both. And that leaves me with x squared plus 3. Okay. Finally, it's going to give me x squared minus 1 and x squared plus 3. Okay, I'm going to go look for my answer. X squared minus 3x squared plus 1. No. Okay, that's 3 pieces. I don't see it. I also know that that doesn't work for my last one. But that's because x squared minus 1 is factorable again. X squared minus 1 factors into x minus 1 and x plus 1 because of difference of two squares. Or if you wanted to factor that out, you could. X squared plus 3 would be my other piece. So in fact, we're looking for choice B. You might also have gotten that if you saw that this has x squared minus 3, which doesn't work in our function either. Once again, if instead you wanted to go forward with this instead of factoring, so x squared minus 3 and x squared plus 1, do some double distribution and see which one gives you the question. That's totally okay here. It's not what the question's asking you to do, but it is a way to solve this problem and get credit for it. Here we've got a combination of like terms. I'm going to start with my first piece, k, and I'm going to look over here. I've got minus 5k. K minus negative 5k is going to be positive 6k. 2k squared minus k squared is going to be 1k squared. And then negative 2k to the third minus negative 2k to the third cancels out. That would give me 0 as an answer. We're going to solve by factoring. In this case, there are not any good numbers for me to divide by that all these are divisible by, so I've got to do this the long way. The first thing to do is do 25 times negative 32. That's my A times C number. And 25 times 32, negative, is going to be negative 800. So I'm looking for things that multiply to negative 800 and add up to negative 20. So I'm going to start with things that are pretty close together. For example, 10 times negative 80, give me negative 70. Not really what I'm looking for. Okay, how about 20, and that's times negative 40. And wow, that actually worked. I got the second try, which was better than I was expecting when I'm trying to multiply negative 800. Okay, so in doing this out, we're going to go with 25x squared plus 20x minus 40x minus 32 is equal to 0. Okay, first two have a 5x in common, and I'd be left with 5x plus 4. The next two I can divide by negative 8, and I'd be left with 5x plus 4. We've got a winner. I love when that happens. That gives us 5x minus 8 multiplied by 5x plus 4 is equal to 0. Okay, in other words, 5x minus 8 is equal to 0, which means that x is equal to 8/5, and 5x plus 4 is equal to 0, which means that x is equal to negative 4/5, which happens to be answer choice D. As an alternative, if you can't figure out the answer for this, if you plug these numbers in and both of them are give you answers that you're looking for, that would be the right answer. So for example, if I did 25 3/2 squared minus 20 3/2 minus 32, and that equaled 0. And if I plug that into my calculator, I find out that that doesn't work. That does not equal 0. That eliminates that answer. I can do the same thing for B and do 25 negative 1/7 squared minus 20 times 1/7 minus 32 equals 0. And if I try to plug that in, I also get that doesn't work. By the time you got to D, you'd find out that the other three answers didn't actually work pretty quickly. And if you didn't feel like factoring or couldn't remember how to factor, that's another way to approach that problem. For number 31, we've got a solve by completing the square. And this one I set up by first, I'm going to rewrite this so I can see a little bit better. And first thing I'm going to do is to write this and move that 34 to the other side. So we get x squared plus 20x
I'm going to minus 34 to both sides, and we get negative 31. Okay. Next step, I don't have anything to divide by because that's a 1 out front. So I'm going to split up my middle term into two equal pieces. So we got 1x squared plus 10x plus 10x. That equals negative 31. Okay? To that, I'm going to multiply these two numbers together. 10 times 10 is 100. I'm going to add 100 to both sides. So we get 1x squared plus 10x plus 10x plus 100 is equal to negative 31 plus 100. That side is going to be positive 69. The other side, we're going to factor. So we get an x out of the first two, and I've got x plus 10. We've got a 10 out of my next two, and an x plus 10. That leaves me with x plus 10 times x plus 10, or x plus 10 squared, is equal to 69. At this point, you might notice that the only one that has an answer that works with this setup is probably that last one. But let's just finish this to confirm. If we square root both sides, x plus 10 is equal to plus or minus the square root of 69. And then if we subtract 10 from both sides, we get negative 10 plus or minus the square root of 69, which happens to be choice D. And again, we kind of noticed that was going to happen about here because we knew we were going to take a square root. The only one that has a square root of 69 is that last one. All right, we got to find all zeros and then sketch a graph. Zeros, in other words, x-intercepts, happens when we multiply to get 0. So we've got x is equal to 0. We've got 3x plus 5 is equal to 0. And we've got x plus 3 is equal to 0. Plotting those, we're going to have 0. This would be negative 5/3. And that's going to be somewhere bigger than 1 and less than negative 2. And then we're going to have negative 3 as our third 0. Okay. Other stuff that I might use from this. This is a positive graph, and I've got 1, 2, 3 pieces. So we're looking at degree 3. And we're looking at a leading coefficient of positive value. So at the end, our graph's going to go up. That suggests that if we kind of loop through, we end up with something that looks like this. We've got a graph of quadratic. We talked a lot about doing this with tables or doing this based on some information in the problem. Let's talk about the table first. Ideally, we set our table centered around whatever the middle number is, and that's going to be 6. Whatever makes the parentheses equal to 0. If I plug that in, I get 6 minus 6 is 0, squared is 0, plus 1 is 1. All right, 6 comma 1 is my first point. I'm going to go up and down, and then up one more and down one more. 7 minus 6 is 1, squared is 1, plus 1 is 2. It'd be 7, 2. And then if I go to 5, 5 minus 6 is negative 1. Negative 1 squared is positive 1, plus 1 is 2. I get this nice symmetry that we should be expecting. 8 minus 6 is 2, squared is 4, plus 1 is 5. So we're looking at 8, 5, and then 4 end up at the same height, which gives me a graph that looks something like this. The vertex for this graph was at 6, comma 1. You can get this either from graphing or by looking at this form and realizing that the x-coordinate is the opposite of what's inside. The y-coordinate is that number, so 6, comma 1. Sketching a graph of absolute value. Again, I'm going to start off with making a table. And I'm going to choose whatever makes that equal to 0. So that's going to be -3. That's my middle value. Let's go up a couple and down a couple from there. I only need 3 values for this time, but I'm going to do 5 anyway just to make sure. So -3 plus 3 is 0. -0 is still 0. -4 is -4. That's my first point. If I do -2, -2 plus 1 is going to be 1. I'm sorry, -2 plus 3 is 1. Absolute value is still 1. Negative makes it negative. So -1 minus 4 is -5. If I go up another one, -1 plus 2 is 2. Absolute value is still 2. -2 minus 4 is -6. If I go to -4, -4 plus 3 is -1. The absolute value makes it +1. The negative up front makes it negative. So -1 minus 4 is -5. If I plug -5 in, I'll get -6 is the answer. This graph is going to look like this after I plot these points. Here we go, Mr. Powers, Mr. Bankell buying notebooks and calculators. Mr. Powers buys 4 notebooks and 2 calculators. And total of 38. This sounds like a system of equations problem. I wonder if it is. So that'd be 4 notebooks. I'll just use X for notebooks. Plus 2 calculators. I'll just use Y for calculators. Equals 38. Mr. Bankell buys 6 notebooks and 3 calculators for 57. 6 notebooks plus 3 calculators is equal to 57. All right. Write an equation for Mr. Powers purchased using the number of notebooks and the number of calculators as your variables. Because I made something stupid with this equation, I'm going to change this to $60. Okay. You don't need to worry about why I'm doing that, but this doesn't come out so nicely if you don't do that. Write an equation for Mr. Bankell's purchase. Oh, we already did that. Determine the cost of the calculators and the cost of the notebooks. I've got to solve this system of equations. This is still going to be awful, but that's okay. So you've got 4x plus 2y equals 38. And we've got 6x plus 3y is equal to 60. It just so happens that if I multiply the top of this by 1.5, I end up getting 6x plus 3y is equal to 57. Now if I go to subtract these two equations, I get 0 is equal to 3, which means that there's no solution. Hurrah! All right, now for graphing these guys, which is also going to be a little bit unpleasant, it might be easier to convert these to slope-intercept form. So if I take the first one, 4x plus 2y is equal to 38. I'm going to minus 4x to both sides, divide by 2, and I get y is equal to -2x plus 19. All right, so that'd be somewhere in there. And down 2 over 1 is going to give me a slope that comes in like this. Graphing in this is so much fun. So 6x plus 3y is equal to 60. Same thing. And up with y is equal to -2x plus 30. And if I graph that, oh man, those lines don't intersect. I wonder if I could have predicted that with anything that I had come up with before, like perhaps no solution? Parallel lines do not intersect, therefore we have no solution. Here's a nice freefall problem. We got Angel Falls in Venezuela, which, if you didn't know, is the waterfall in the movie Up. Is 3,212 feet tall. We've got a function that models the height in feet of an object t seconds after it is dropped. Okay, after how many seconds will the object hit the ground? The ground means y equals 0. So 0 equals negative 16 t squared plus 32, 1, 2. Okay, I've got to solve for t. To get t by itself, I'm going to add 16t squared to both sides. 32, 1, 2. I'm going to divide both sides by 16. And I get t squared is equal to t squared equals 200.75. I totally did that in my head and not on the calculator on my computer. That means I'm going to do the square root of both sides, and I get t is equal to plus or minus. And again, I'm totally doing this in my head, not in the computer. 200.75, 14.1686 seconds. Nearest tenth of a second, so that's 14.7 seconds. And I only really care about the positive one because we're talking about time, and negative time means seconds ago, not seconds in the future. What is the height of the object 5 seconds after it is dropped? In other words, when t is equal to 5. So y equals negative 16 times 5 squared plus 32, 1, 2. Okay, well 16 times 5 squared is going to be negative 400. So we got negative 400. And that's plus 32, 1, 2 is equal to 28, 1, 2 feet off the ground. And finally, initial upwards velocity of 32 feet per second. How long will it take for the objects to hit the ground? So we've got a new lovely equation. So hit the ground is going to be 0 again. Negative 16t squared plus 32t plus 3212. I'm going to clean this up a little bit by dividing everything by negative 16. And we get t squared is equal to t squared plus negative 2t. And 3212 divided by 16 we already did once, minus 200.75. Not factorable, but I could totally complete the square for that. So t squared minus 2t is equal to 200.75. T squared minus 1t plus 1 is equal to 201.75. T minus 1 squared is equal to 201.75. The square root of both sides, and again, totally in my head, not from a calculator on my computer. I get the square root of 201.75 is 14.2, which means that t is equal to 15.2 by adding 1 to both sides. This should be plus or minus. Since we're dealing with time after we throw something, we only care about the positive version. Third word problem. Mr. Carlson, hey, that's me, is building a set of boxes to store his Legos, but I spilled coffee on my plans? That sounds terrible. This is what we know. The volume of the box. Okay, I'm going to draw a box. I am such a good artist. So the volume is going to be 72 inches cubed. The bottom of the box was square. Okay? The bottom was 4 inches longer than the height, x. Okay, so the height is x. If the bottom is 4 inches longer, that'd be x plus 4. And if it's square, that would be x plus 4 also. I also know that volume is equal to the base, so x plus 4, times the width, x plus 4, times the height of x. Hey, I just accidentally answered the first part of the problem. Solve the equation for the specific volume of Mr. Carlson's Lego box. So that's that 72 number. 72 is equal to x plus 4 times x plus 4 times x. So in other words, 72 is equal to x cubed plus 8x squared plus 16x and 0 is equal to x cubed plus 8x squared plus 16x minus 72. All right, to solve this, not factorable. I've got to come up with some alternative way to do this. That alternative way to do this might be to do some rational root theorem. Okay. So we're looking for numbers that multiply to get 72. 1, 2, 3, 4, 6, 7, 8, 9, and then I can work backwards. So you've got 12. Oh, why did I choose this problem? 18, 24, 36, and 72. Awesome. And when I go to try some of these things out, all these got to be plus or minus. I don't know. Let's try 2 perhaps. Or maybe negative 2. So that'd be 1, 8, 16, negative 72. 1, negative 2, that gives me 8, negative 2 is 6. Negative 12. 16 plus negative 12 is going to be 4, negative 8, and that does not work. How about positive 2? My original gut instinct. All right, we got 1, 2, 10, 20, 36, 72, and 0. Nice. So that's going to be x minus 2. Then we've got x squared plus 10x plus 36 is equal to 0. All right, this one, that's when x equals 2. By the way, that's going to be our answer. For the other part, I'm going to zoom out a little bit and do some work over here. So now we've got x squared plus 10x plus 36 is equal to 0. I could either factor, not going to work, or complete the square, or do the quadratic formula for this. Let's complete the square. Minus 36 to both sides. So we've got x squared plus 5x plus 5x is equal to negative 36. And that means I'm going to add 25 to both sides. X squared plus 5x plus 5x plus 25 is equal to negative 11. Means that x plus 5 squared is equal to negative 11. Square root both sides. We get x plus 5 is equal to plus or minus the square root of negative 11, which is an imaginary number. That's interesting. That means that x equals 2 is our only valid length for a side. You might notice that the second part of this question is how many real solutions are there? There's only one real solution. The other are imaginary, and those are numbers that just don't work for this box. What are the dimensions of Mr. Carlson's Lego box? Well, if x equals 2, that's my height. That means that x plus 4 is equal to 6. And if I do 2 times 6 times 6, I get 72. Hey, that worked. We've got to solve this system of equations by elimination. And by elimination means I'm going to multiply by something to get a coefficient the same, and then add or subtract 2 of these equations. So the easiest thing that I notice is that I've got a negative 1y and a positive 11y. If I multiply this first equation by 11, we get 77x. We get negative 11y equals negative 176. Often that's the part that people forget, is to multiply this last piece as well. Now if I were to add these 2 equations together, so we're talking about these two. 8x plus 77x is 85x. 11 minus 11 is 0, that's nice. And then 6 plus negative 176 is negative 170. Dividing both by 85, we end up with x equals negative 2. I'm going to use that x to plug back in. I'm going to go with the first one because that looks like an easier equation. 7 times negative 2 minus y is equal to negative 16. That means negative 14 minus y is equal to negative 16. I can go a step further and add 14 to both sides. Negative y is equal to negative 2. To get rid of that negative y, I'm going to divide both sides by negative 1, and that gives me positive y is equal to positive 2. My answers are x equals negative 2 and y equals 2, or I could write that as the ordered pair, negative 2 comma positive 2. We're looking at another system of equations. This one we're going to solve by elimination again, and what I'm going to look for is the way to make two of the coefficients the same. I noticed that 18 and 9 are related, that if I multiply the bottom equation by 2, I should get 18 as a result. I'm just going to bring this guy down here, so negative 18x plus 8y equals 24, just rewriting that. And now 2 times 9 is positive 18x. 2 times negative 7y is minus 14y. 2 times negative 21 is negative 42. When I add those together, I get 0x. I'm going to end up with negative 6y. And negative 42 plus 24 is going to be negative 18. All right, if I divide both sides by negative 6, I get y is equal to 3. That's my y answer. I'm going to use that to find my x answer. Neither of these is particularly appetizing. I'm going to choose the second one because the numbers are smaller. So 9x minus 7 times 3 is equal to negative 21. So 9x minus 21 is equal to negative 21. To get the x by itself, I'm going to add 21 to both sides. 9x is equal to 0, and I'm going to divide both sides by 9. And I get x is equal to 0. My solution would be x is equal to 0, y is equal to 3, or the ordered pair 0, 3. Here we've got to sketch the graph of the line. We can do this one of two ways. The easiest way for us to do this is to make a table, and what we're going to do is plug in 0 for x, see what y is, and plug in 0 for y, and see what x is. This is the easiest method for this because this is in what we call standard form. The x and the y are on the same side. So we go 0 plus y equals 3. That means y is 3. That's the point 0, comma 3. If I plug in 0 for y, that's going to be x plus 0 equals 3. That means that x equals 3. I'm going to plot that point. My line has got to go through those points, and I have graphed my line. So I guess this didn't record while I was writing that out. So the first thing we did here was notice this was in standard form. And for that, we plugged in a 0 for x and a 0 for y. 0 for x gave me negative 4 for y. That's where that point came from. Plugging in 0 for y gave me x equals negative 2. That's where this point came from. And I drew a line between those 2 points. We've got to write the equation of a line through the given points. For any line, we need at minimum a point, which we've got 2 of, and we need a slope. I'm not specifying a form for this. The easiest one for me to use is point slope, which is y minus y1 is equal to the slope times x minus x1. Okay? First thing we need to find is my slope. So to do that, we're going to take our points, and I'm going to subtract my y, so negative 2 minus negative 5. I'm going to subtract my x's, negative 3 minus 0. I've got to keep the same order, so I connect those two and those two. And when I do that, I get positive 3 on top, negative 3 on the bottom, which is negative 1. Okay, that means that my slope number is negative 1. I can use either point, so I'll use both in this case. If I make this the point I use, we get y minus negative 2 is equal to negative 1, x minus negative 3, and you're done. If I chose to use the other point, it could be y minus negative 5 is equal to negative 1, x minus 0, and you can finish there. You don't need to go any further. Here we're going to graph this line. This is in slope-intercept form, so that's y equals mx plus b. I know that plus 1 is my y-intercept, and I've got a slope of negative 1 over 5. That means down 1 in 1, 2, 3, 4, 5 units to the right. I'm going to go through those 2 points, and it looks something like this. Here we're looking at polynomials. We've got a factor, identify x-intercepts, identify y-intercepts, and sketch a graph. So first things first, let's try to factor this. This is 4 pieces already, so I'm going to factor by grouping. First 2 have an x squared in common, and I'm left with an x plus 5. For the next 2, I can factor out a minus 4, and I'm left with x plus 5. That means I've got x plus 5 and x squared minus 4. X-intercepts, I've got to set both of these equal to 0. So we can do x plus 5 equals 0. We get an x-intercept of negative 5. We get x squared minus 4 equals 0. I can add 4 to both sides. I can take the square root and I get x equals 2 and x equals negative 2. For the y-intercept, I need to plug in 0 for x. And I can do that just in the equation they give me or in my factored form. It's a little bit easier to do it in the equation that I'm given than having to rewrite this. Please remember that f of x just means y. So y equals 0 plus 0 minus 0 minus 20. We've got a y-intercept of negative 20. Okay? And just for checking, we have a positive leading coefficient, positive 1. An odd graph, this should look something like an n. Okay, my y-intercept, negative 20. My x-intercept's at negative 5, negative 2, positive 2. I'm going to draw in my end behavior. I know this should be going up because that's positive. I've got to make sure I hit my y-intercept, go through my x-intercepts, and my prediction of my shape was right. Here we've got a sketch graph of a piecewise function. We're given w of x is equal to negative 1 for x is less than negative 2, 4 between negative 2 and 4, and negative x plus 4 for x is greater than 4. First thing I'm going to do is to draw in my barrier. So we've got negative 2, and we're going to have positive 4. Okay? So what we're doing is I'm going to put y equals negative 1 in the spot for less than negative 2, just so I can see where that is. I'm going to write y equals 4 in the spot between negative 2 and 4. And finally, I'm going to put y equals negative x plus 4 for that last part, when x is greater than 4. Okay. And I'm going to try to graph each of these pieces. Y equals 1 is a horizontal line at x equals negative 1. The only part of this that I care about is in this leftmost section. So that's going to be this segment down here. I'd like us to notice that A and B both have that line segment drawn. C does not, and D does not. My second graph, y equals 4, is going to be a horizontal line at a height of 4. And that is only going to matter in the middle of those two pieces. So we're looking at this segment up here. If I take a look at my two graphs, both of these have graphs that work for that. In fact, both of them have the same last piece also, which means I'm going to have to pay attention to my endpoints. Okay, so for -1, that's when x is less than -2. That's an open circle because it's just less than. For 4, both sides, based on my two inequalities, should be closed endpoints. If I take a look, the first one fits that, the second one does not. And finally, when I graph this third piece, so y equals -x plus 4. So 1, 2, 3, 4. It's going to have a slope of -1, so it's going to go something like this. We only care about this line in this third region, and because we've got just greater than, this has to have an open circle, which is exactly what choice A gives us.